2, 1. Hey, today we are graphing transformations. Like I said, what we're doing tomorrow, Wednesday, exact same thing, but opposite. Go ahead and throw your name on here. It is currently first hour. Okay, so the first thing that we need to look at is we need to look at what we are calling our parent functions. So we have 3 parent functions. We're actually only going to be transforming 2 of them, but we have the shape of 3 functions that we've been looking at this unit. The first one is a linear function. A linear function is the function f of x equals x. So if I were to plug in 0 there, then I would have 0. So 0, 0, 1, 1, 2, 2, 3, 3, so on and so forth. The next function that we are looking at is f of x equals x squared. So I want to show you these 5 key points on here. If I were to plug in 0 here, I would do 0 squared. What is 0 squared? 0. So that's why I have a point right here at 0, 0. Then, moving in this direction, if I were to plug in 1, I would do 1 squared. 1 squared would be 1. And then continuing moving in the positive direction, 2 squared would be 4. So if we see, I have a point at 0, 0, 1, 1, and then 2, 4. Going in the negative direction for my quadratic, I have negative 1 squared, which is also positive 1, and negative 2 squared, which is 4. So when we are making the shape of a quadratic graph, what you can do is you can start in the middle, and then from each side you can go up 1, out 1, and then you can go up another 3, out 1. So up 1, out 1, up 3, out 1. So if you want to put a little note to yourself of how we're going to graph these, it's going to be up 1, out 1, and then up 3, out 1. I guess you could go out and then up, but that's how I think about it. Because we are going to end up graphing that exact same shape in different places around our graph. Okay, and then the last parent function that we are looking at is the absolute value parent function, which I had told you guys last week is V-shaped. Absolute value is the distance from 0. How far away is 0 from 0? 0. How far away is 1 from 0? And how far away is 2 from 0? 2. So that's why I've got points at 0, 0, 1, 1, and 2, 2. Then how far is negative 1 from 0? 1. So distance is always positive. We talked about that back in Unit 1 when we were solving absolute value equations. Distance is always positive. So absolute value of negative 1 is 1. Absolute value of negative 2 is 2. So that's why it goes up and out on both sides. So if you're trying to remember the shape for this one, it's going to be up 1, out 1. And then up 1, out 1 again. So there are your 2 shapes that you're going to need for today. Alright, so we've got these 2 shapes, and then what we're going to be doing with them today is we are going to be transforming them. So parent functions can be either transformed or moved. Transformed is just a fancy way of saying moved. Today we will be transforming our quadratic and our absolute value functions. Abbreviate absolute. I didn't make that blank long enough. And then there's a little note there. We already learned how to graph linear functions in Unit 2. So you could transform a linear function. That's not the most practical way to graph a linear function, though. The most practical way to graph a linear function is slope-intercept form, which we did in Unit 2. So we're not going to do that again in a less practical way, because it's not a good use of anyone's time. Okay, so we've got our 2 parent functions that we are going to be transforming today. We're now going to talk about where they're going to go. For today in Algebra 1, we are just taking that parent function, the exact shape it is, and we're going to be moving it up and or down, left and or right. When you guys get to I don't know if, do we do transformations of functions in algebra 2? Or, sorry, in geometry. I know they do them in algebra 2. I feel like you do some with them in geometry. I feel like you do. You, not yet, maybe. Do you do transformations of functions? Yeah. Okay. So, you might see this next year. You're definitely going to see it in 2 years. You are going to start taking your graph and making it wider and narrower and like stretching it horizontally and vertically, and you can flip it around and you can rotate it. I know you do that in geometry. So there are other things you can do with your graphs for this year in Algebra 1. All we're doing is moving left and right, up and down. We have to start somewhere, and that's where we're starting. Okay, so moving down, we are going to fill in this table, and this is going to tell you where your graphs move. So there are 4 possible directions your graphs can move today: up, down, left, and right. If you add inside a function, you are going to move to the left. If you subtract inside a function, you are going to move to the right. I am going to give you an example of what adding inside and subtracting inside looks like with these 2 functions we're going to look at. So with a quadratic function, that would be f of x equals, and then inside parentheses, let's put x plus 4, and then close your parentheses squared. We're just using 4 as our example. That's just a random number I picked. So that's what it would look like to add inside a quadratic. To add inside an absolute value would look like this: f of x equals absolute value of x plus 4, then close your absolute value signs. So that's what it would look like to add inside. And then subtracting inside would look the exact same, but with subtraction. So f of x equals x minus 4 squared. And f of x equals absolute value of x minus 4. So that is how you would move left or right. With these 2 random examples I put, this would mean you were moving left 4. This would mean you were moving right 4. But obviously, you could add or subtract a different number there. Grab a note sheet, please. Okay. Then, if we want to move, that one. If you want to move up or down, you're going to be adding or subtracting outside. So if you want to add outside, that is going to move you up. Subtracting outside is going to move you down. So what that's going to look like for adding inside and outside. For adding outside, it would be f of x equals, I would have my x squared, then I would be adding after the squared. So let's put a plus 4 there. For an absolute value one, I would have my f of x, and I would have the absolute value of x, and I would be adding outside of that. I would be adding after. Okay, and then the last examples, subtracting outside, it's going to be exactly like this, but instead of adding, we're subtracting. So I've got f of x equals x squared, and then I'm subtracting something, or f of x equals absolute value of x, and then I'm subtracting something. Okay, so we have all of these different examples here, and you're gonna look at them and be like, okay, well, they're all just x squared with plus or minus a number. You gotta pay really close attention. Inside versus outside, adding versus subtracting. That's gonna take you to your 4 different directions, okay? You gotta pay attention to where your operation's happening and whether it's adding or subtracting. Any questions right now? Okay, help me remember. I will put this table back up on the screen while you guys are working on your assignment, because this is what you're going to need to be able to do the examples on the back and do the problems on your assignment. So flip this over, and we are going to start graphing our transformations. So there's 2 things you've got to decide. Wow, that green marker really bled through. I should not use green next hour. Oh well. Okay, you got to decide which your parent function is. We only have 2 options today. We've got x squared and the absolute value of x. There's other parent functions in the world, but those are the 2 we're using right now. Then you've got to decide what your transformation or transformations, because sometimes there's going to be more than one, are. So this first one here, we've got f of x equals x squared. Our parent, or x squared plus 3, our parent function is x squared. So we can just look and ignore anything we're adding or subtracting, and that's going to be your parent function. Then you look at what operation or operations you're doing. I am adding 3 here. Is that inside or outside the x squared? Outside. So I'm adding outside. So you use your table, and once you guys get halfway through your assignment, you're probably going to have these memorized. Adding outside, add outside, tells me I'm moving up. So that means I need to take my function, and I need to move it up 3. So instead of starting my parent function right at 0, 0, I'm going to start at 0, 0, I'm going to move straight up 3, and I'm going to put a dot. That is going to be the new bottom middle of my parent function, and I'm going to graph it from there. So this one's the x squared one. So to do the shape for x squared, I'm going to go up 1, out 1 on each side. And then I'm going to go up another 3 and out 1 from there. So up another 1, 2, 3, out 1. That puts me all the way at the top. Up another 1, 2, 3, out 1. We need you to draw those 5 little points on. And then you can connect them to a nice little U. Alright, any questions on that guy? Alright, the next parent function we have is the absolute value of x. So if I just ignore that minus 2, it's absolute value of x. And then I am subtracting inside on this one. So if you see the minus 2 is inside the absolute value sign. So if I am subtracting inside, we can use our table. Subtracting inside moves me to the right. So I need to move to the right 2. And the number always tells you how far you're going. So right 2. So once you've given yourself those directions, then it's smooth sailing from there. You can just graph it. So we're going to start at 0, 0. Instead of putting a dot there, we move right 2. And then we can just graph our absolute value from there. So for the absolute value one, it's a V, so you go up 1, out 1 on each side. I do that twice. Get my nice little V shape. Any questions there? Okay, we are going to start moving on. The rest of the problems on here and most of the problems on your assignment are going to have two transformations. So we're going to have something happening inside and something happening outside. Whatever is happening inside, we're going to deal with first. That is either going to take us left or right. Then whatever's happening outside is going to take us up or down. So just like with an ordered pair, that we go left or right and then up or down, that's what we're doing with these as well. So this next one, our parent function, we've got x squared. So we just ignore the plus 5 and ignore the plus 3 for a second. So our parent function is x squared. And then we are adding 5 inside and adding 3 outside. So that's two separate transformations that we're going to deal with in the same problem. So adding inside, add inside is going to move me left. And then adding outside is going to move me up. So I am going to be moving left 5. I'm just going to write L5. And I am going to be moving up 3. Your first transformation is always going to be left or right. Your second transformation is always going to be up or down. Just remember that. You got to go somewhere before you can go up or down. You got to go left or right before you can go up or down. Okay, so now when we are graphing this, we want to graph it all together. We don't want to like try to do two things separately. So you're going to start at 0, 0. Sorry, I'm skipping these. You're going to start at 0, 0. You're going to move your pencil left directly 5, then up directly 3, and then put a dot there. That right there is the bottom middle point of your graph. Then we look and we see which parent function it is. It's x squared. So we are going to plug in, or we're going to go up 1, out 1 from each side there, and then up 3, out 1 from each side there. So up 1, out 1 on each side, and then up 3, out 1 on each side. Okay, any questions right now? We have 3 more of these, so you guys can see it happening with an absolute value, and you're going to see it happening in all 4 quadrants of your graph, so we'll end up with 1 in each quadrant. Just so you've got lots of examples to use on your assignment. So, last 3. These all have two transformations as well. Let's go through and do our parent functions on all of them. This one, ignore the plus 4 and minus 3. My parent function is absolute value of x. This one, ignore the minus 3 and the plus 1. My parent function is just x squared. And then this one, ignore the minus 4 and the minus 2. My parent function is just absolute value of x. So for your parent functions, just ignore whatever you're adding and subtracting. Okay, so this first one, we need to move left 4 and down 3. I probably shouldn't have just done that. So if you use your table, adding inside moves me left. So left 4. And then subtracting outside moves me down. So it's going to be left 4, down 3. So start at 0, 0. Move left 4. Move down 3. And then our function needs to be the absolute value one, which is our V-shaped one. So I go up 1, out 1 on each side, up 1, out 1. I didn't say that, I just did it. Okay, instead of me just giving it away this time. Subtracting inside, where does that move me? Right, so the inside is always going to be left or right. So subtracting inside moves me right. And then this would be adding outside. What does adding outside move me? Up. Yep, so right 3, up 1. So keep using that table until you got them memorized. So right 3, up 1 would be right here. And then I'm making that good old U-shaped graph, so I'm going to go up 1, out 1 on each side. And then up 3, out 1 from each of those. Oh, I forgot to go out. I made a little boo-boo. Okay. Connect that. Hey, very last one, I'd like for you guys to try it on your own, and then we'll check it together. So use your table, figure out your 2 transformations, and we'll check it together. Hey, which transformation did you guys do first? What did that -4 tell you to do? Right 4. Awesome. I agree. So subtracting inside moves me to right. Then what did this -2 tell me to do? Down 2. So outside subtracting tells me to go down. So I would go right 4, down 2, put a dot, and then I can make my graph from there. So I'm going to go up 1, out 1 on each side 2 times. Up 1, out 1 on each side 2 times, because it's that V-shaped absolute value of x. Hey, I could take the time to explain to you guys that if I were to plug in any number for x, it would match up with this. I'm going to do that once real quick in our heads. So right here, if I were to plug in x equals 5, I would do 5 minus 3, which is 2. 2 squared is 4. 4 plus 1 is 5. So that's why I have a point right here at 5, 5. And you do the same thing with 4. 4 minus 3 is 1. 1 squared is 1. 1 plus 1 is 2. Go over to 4, 2. So I could plug in values for x every time and then find corresponding y values. But we know that these rules exist, and so we could just use the table instead of having to plug in separate values and do the math a bunch of times. And then we wouldn't even know which values to plug in either to figure out which way it was going to scoot. So with that being said, go ahead and glue in your notes. We got about 10 minutes to work on our assignment today, and then we'll give you guys some time to work on your assignment on Wednesday at the beginning of class, or Tuesday if you're watching this video and you are an even-houred class. So I'm going to stop the video, and then I'll bring you your assignments.